Okay, back on. If I can ever get this thing figured out. Okay. Okay, back on. I think I had it figured out. Sorry, guys. I'm gonna zoom in a little bit here without trying to mess up. Hopefully we can see a little bit better. All right, welcome back. So, again, I don't know what the focus issue is with this thing. I don't know why it does not focus. I don't know if that's the live stream issue that we have, but you guys have the paper, so you should be able to see what's going on here. I'm going to try to move my tripod a little bit so that this is a little bit more even. Okay, so hopefully you guys can see this. If you can't see it, this is the review. So I'm going to go ahead and start on the review. I can see you guys on the side if you have comments or questions. So just let me know if you're stuck on something, okay? All right, so we'll start off doing the review. So we'll start number 1. Okay, so number 1 says, given segment RS with endpoints R at negative. Okay, I've turned off the background. I don't want to hear myself talk any more than I already have to. So I have endpoints R, -2, 4, and -6, -2, and I want to find the midpoint of the segment. Okay, I want to find the midpoint of the segment. I know y'all love having Keanu Reeves staring at you. Okay, well, midpoint we know is the average of the coordinates. We have a midpoint formula, and you can use the midpoint formula, but it is the average of the 2 coordinates. So if I'm looking at my 2 endpoints here, I've got R and S. I'm going to draw my segment so you can see it. I've got R that's located at -2, 4, and I've got S that's located at -6, -2. And I want to find the midpoint. And you can think of this several different ways. The first one is that we are looking at for the average of the X's and the average, and the second one is the average of the Y's. So I'm going to look at the 2 X coordinates first. I've got -2 and 6. So I want to know what is midway between these 2 guys. What is halfway between -2 and -6? And in order to do that, I'm going to do -2 plus -6 divided by 2. I'm going to take the average of the 2 coordinates. So -2 plus -6 is -8 divided by 2, which is -4. Negative divided by positive is negative. So that's the X case. That's the X's. So now let's find the Y's. Okay, I'm going to slide this over a bit. My 2 Y values are 4 and 2. So if I want to find the midpoint, again, you're adding. You add the 2 coordinates. Here, I added the 2 coordinates. A lot of you mess up because you use subtraction, like the slope formula. We want to add. So I've got 4 plus 2 divided by 2. 4 plus 2 is 6. So I've got 6 divided by 2, which is +3. So that is my Y coordinate. So this point that's located exactly halfway between these 2 is at -4, +3. That's the midpoint. Okay, that's the midpoint. If anyone has any questions on that, let me know. Like I said, you can type it in the chat bar area. Okay, so I'm going to go ahead and move on to Phineas and Ferb. As someone pointed out today, yes, I know Phineas and Ferb are brothers and they wouldn't live in different houses, but we don't care about that, right? Because we need a problem for math. Okay, this one here you have, on your review, you have, I think you've got Phineas at one place and Ferb at another. So what I'm going to do is I'm going to end up finding how far apart. What does how far apart mean? That means distance. I want to know how far apart they are. So how far apart are those 2 houses? Well, first of all, I have to find the coordinates. So Phineas' house is located at -1, 1, 2, 3, 4, 5, 6, 7. So Phineas is at -1, 7. Ferb is located at 5, 1. So now I've got my 2 points. So in order to find out how far apart they are, all I have to do is find the distance formula. So I'm going to use the distance formula. Okay. Is it on, for the Phineas coordinate? This one is at -1 up here, because you're over 1, -1, +7. Here you're at 5, 1, +5, +1. Okay. So if I want to find the distance between the two, I'm going to use the distance formula. And I'm going to draw a better line than that. I ran into the tripod. So I write my distance formula out. Remember I told you to write out the... Oh, the names are mixed up, sorry. I guess we could have Phineas and Ferb here. You're going to get the same answer. I printed this off my printer because all of my ones are at school. Sorry about that. So anyway, we'll switch them. Phineas and Ferb. I'll put them here. So Phineas is here and Ferb is here. So that means they're switched there. So you're going to end up getting the same thing. So what I have here is I have my x's are -1 and 5. So I'm going to plug in -1 and 5. That's my x coordinates. And my y coordinates are 7 and 1. So I'm going to plug in 7 and 1. So now I have -1 minus 5 is -6. You keep it in the parentheses. And 7 minus 1 is 6. Okay. So when I do this, I get -6 squared is +36. And 6 squared is +36. So I have -36 and 36, which is 72. And if you do the square root of 72, you're going to get 8 point something. So if I were to bring my handy dandy calculator here, oh man, I'm going to have to get some more batteries. If I hit second and the squared key, that gives me the square root. I'm going to put in there 72 and I get 8.4. So the actual distance between their houses is 8.4. That's how long that segment is on the graph, is 8.4. Okay. Does that make sense? Hopefully. Sorry I got the names mixed up. I printed this one off the printer and I wrote all the stuff in. I didn't make it home with a copy, so I had to print one here and I had to write a lot of the stuff in myself. Okay, so that is that one. Now this one here I had quite a few questions on today. This one here says, given these points, tell me which segments are congruent. Now congruent is the same length. So for number 3, I've got X, Y, J, and K. And all of these mean distance. Whenever you have the 2 points and something above it, it's just distance. So what we have now is I've got X, Y. So I'm going to find the distance from X to Y. X is at -3, 5. And Y is at 4, 7. So I'm going to find the distance between these two guys to figure out how long segment XY is. On the test, you'll be asked to find the length of segments and determine if they're congruent. So I'm going to set up my distance formula. Set up my distance formula. And I'm going to start plugging in values. So what are my two x's? -3 and 4. And my two y's are 5 and 7. So I've got this all plugged in. So at this point, you can plug this into the calculator without doing all the extra. I'm going to go ahead and do the extra just so you can see the steps, but if you put an extra set of parentheses around here, you can put it in the calculator and check your answer. So -3 minus 4 is -7. So you got -7 squared. 5 minus 7 is -2, so you have -2 squared. -7 squared is 49. 2 squared is -2 squared is 4. Remember, anytime you square a negative, it becomes positive. So I've got the square root of 53. That's how long this one is. Now, if you actually wanted to put that in and see what it was, you have the square root of 53. Whoops. you would end up with 7.3. Okay? So you've got 7.3. So that's approximately 7.3. Okay, that's how long that segment is. So the next question down here is asking about which ones are congruent. Well, you basically have to do this for all 4 of them and see which ones match. So let's do the next one. JK. So J is 1, 2, K is 8, 10. So I'm going to do the same thing. I'm going to do the distance, make my formula. Now, what are my 2 x's? 1 and 8. My 2 y's are 2 and 10. So I get the square root of -7 squared plus -8 squared, which is going to be -7 squared is 49, -8 squared is 64. So when I add these together, I get 113. And again, if you want to do that in the calculator, you do second, yes, I know it's second square root of 113, and you get 10.6. So this one is 10.6. So we know for sure right now that these two are not congruent. They're different sides, they're different lengths. This one's 7.3 and that's 10.6. So this one has to match up with one of these, and this one has to match up with one of these, because that's the way I set it up. So let's do the next one. XJ, X is at -3, 5. J is at 1, 2. So I'm going to do my distance, set up my formula. Okay, my 2 x's are -3 and 1, so I'm going to plug in -3 and 1. My 2 y's are 5 and 2. So the distance is going to equal -3 minus 1 is going to be -4. And 5, let me make sure I've got the right ones. -3 and 1 and 5 and 2. Okay, so I've got 5 and 2, so 5 minus 2 is 3. Okay. And so -4 squared is 16. 3 squared is 9. So I've got the square root of 25, which is what? 5. Oh, but look. That one's different, right? Okay. That one's going to be different than these two. So far, do you see any congruent segments? Okay. They're all different. Well, that kind of leaves us to the last one. Let's find out what's going over here with YK. Okay. KK. So YK is at 4, 7 and 8, 10. Okay? Those are your 2 coordinates. That's Y and that's K. So I'm going to do the same thing. If you hear music in the background, my kids are watching The Nightmare Before Christmas. Occasionally they will burst into song. So I'm going with 4 and 8, right? And I'm going with 7 and 10. So 4 minus 8 is -4 squared. 7 minus 10 is -3 squared. So -4 squared is 16. -3 squared is 9. So we have the square root of 25, which is what? 5. Okay? And this should have been 2 congruent segments, not 2 pairs of. I was thinking pairs because I was doing distance. So which 2 segments are congruent? XJ, which is this one, right, is congruent to what? YK. Why are they congruent to each other? They are the same length. Okay, hopefully that makes sense. That should have said 2 congruent segments, because you had to match the 2 that were the same length. So XJ is congruent to YK. Does anybody have any questions on that one? On any of the distances? Are you pretty much an expert at the distance formula now? Hopefully? Okay. All right, so that's the first page. Okay, I'm going to go ahead and take this out. Let's look at page 2. Because usually that's what comes after page 1, is page 2. Okay. So on this one, at the top, we have FG. Okay. For segment FG, F is located at 2, -4. So I'm going to draw this segment, FG. F is at 2, -4. And the midpoint is located at -6, -2. Find G. And don't say right there. Okay, so find G. So what I'm going to end up doing is I'm going to stack these. Okay, I want to figure out how did I jump from here to here and how did I jump from here to here, and then I'm going to do the same thing to G. So the easiest way to do this without using the equation is F is here. We're starting at F. We jumped to the midpoint, -6, -2, and we're trying to find out where this one is. So I'm going to use a little bit of color here just because I'm getting bored. Let's figure out, let's do the X values first. How did I get from 2 to -6? What did I do? It's just a review. It's just a review. I'm not going to pick this one up. So you have 2 and -6. To get from 2 to -6, I subtracted 8, right? Because if I'm at 2 and I jump to -6, I'm going to go 8 to the left. No problem. So I'm going to do that again, because if that point's exactly in the middle, whatever I did to get from one side to the middle, I have to do the same thing to get from the middle to the other side. So -6 minus 8 will put me at -14. Okay, so that's my X value. Whoops, move the deal. My back is still hurting me. I'm pretty much locked in my chair right now. And on the Y side, how did I get from -4 to -2? I added 2, right? So to get from the midpoint to the other side, I have to add 2 again. -2 plus 2 is 0. So these are the coordinates of G for the midpoint. Okay? That's the coordinates of G for the midpoint. Remember when they give you the midpoint, sorry, I'm trying to move here. It's not working because I hurt. If I give you the midpoint and one of the endpoints, you have to figure out how we move from one endpoint to the other. Okay? Alrighty then, as Ace Ventura would say, which half of you probably don't even know who that is. Okay, so let's move up to number 5, fractional distance. Fractional distance. I'm going to try to use some colors here as much as I can. So fractional distance is you're taking a fraction of the distance. You're taking a fraction of the distance. So I'm going on the number line from -9, and then there's 0, and there's +7. And I want to know what point is 3/4 of the way between -9 and 7. The first thing I have to do is establish how far apart 9 and 7 actually are. How did I get from here to here? Well, that is the absolute value of the difference. In either order, it doesn't matter. So -9 minus +7, and I'm going to start putting these symbols on there so you can see it's a difference, okay? It's a difference. So I've got -9 minus 7, so that's -16, which absolute value is +16, okay? So these two guys are 16 units apart, but I'm looking for the point that is 3/4 of the distance away. I don't want to go from -9 all the way to 7 and go 16 units. I only want to go 3/4 of the way, just 3/4 of the way. So what I'm going to do with that 16 is I'm going to take 3/4 of that 16. And remember, anytime you take a fraction of a number, you just multiply it by that fraction. So 16 times 3, I can either multiply straight across or I can do some reducing before I multiply. I'm just going to multiply straight across. You got 48 on top and 4 on the bottom, so that ends up being 12. So instead of going 16, I only want to go how many? I only want to go 12. A lot of you are getting into trouble in the fractional distance assignment because you were putting this as your final answer. Like Who Wants to Be a Millionaire, right? Don't we all? You were putting that as your final answer. That's not your final answer. That is the portion of the full distance that you're going to go. You still have to go back to the original point and figure out how many units or where you're going to be when you add 12. So where did I start? I started at -9. So if I start at -9 and I go 12 units, where am I going to end up? I'm going to end up at +3. And that's your answer. Okay, so that's how you do the fractional distance on the number line. Again, you have to find out how far apart they are, multiply that by the fraction to find out how much of that distance you actually want to go. Sorry, adjusting that injured back. And then you have to start at your starting point and add that new distance on. I didn't want to go all 16. I just wanted to go 12. 3/4 of it. Okay, and that put me at 3 as opposed to putting me at 7. Okay, so let's look at number 6. Number 6 is going to be done the same exact way, except now I have X and Y coordinates to deal with. I have 2 different sets of coordinates. So I'm going to draw, I'm going to pretend that I have these on a graph somewhere. One of them is at -9, +7. That's going to be about over here. And you don't even have to do this. I'm doing this just for your visual. And the other one is over 3 over and 2 down. So we're at 3, -2, okay? So first of all, I want to find out what point is 2/3 of the distance, okay? What point is 2/3 of the distance from -9 to 3? That's the x's. And then I want to figure out what point is 2, or what the coordinate is from 7 to -2. Okay? Now, look at the order that I graphed them, and let's be careful. Let me go back and look at this. For segment KL, point K is here. Find the point that is the distance from K to L. So where is our actual starting point going to be? Right here. So we're going to start here and go that way. That's because that's what it tells us. We're going from K to L. K to L. So let's start off with our X coordinates, just like we did in the other one. How far apart is it from 3 to -9? Well, again, absolute value of the difference. I'm going to go from 3 all the way where? To -9. That gives me -12, which is an absolute value. So these guys are 12 units apart. I'm going to put a little thing there. The x's are 12 units apart, okay? So let's do the same thing now for the y values, okay? How far apart are the y values? Well, my y values are 2 at my starting point, 7 at my finish. So I have -2 minus +7. And I told you I'm going to start writing the positives in there because I want you to see everything. So -2 minus +7 is -9. The absolute value of that is 9. So y to y is 9. Okay, do y'all see that? Okay, but I don't want to go that full distance. I only want to go a portion of it. I want to go 2/3 only. So since I want to go 2/3 only, I'm going to do for each coordinate, I'm going to multiply by 2/3. I don't want to go the full 12 for the x's. Okay, these are your x's. I want to go 2/3 of that. So I'm going to multiply 12 times 2/3. And 12 times 2 is 24 over 3, which is 8. Okay, so 8 is how far I want to go. But let's come back to that. Let's do the y values. Again, I only want to do 2/3. So I'm going to take 2/3 of that 9. And I get 18 over 3, which is 6. So what I just figured out is how far I'm going to travel with the x's and how far I'm going to travel with the y's. So when I do this, the only other thing I need to do is establish a direction, because sometimes you're going to be subtracting those distances and sometimes you're going to be adding them based on where you start and where you finish. So if I start at 3 And again, it tells you K to L. It tells you K is your starting point. If I start it, for my x's, if I start at 3 and I go to -9, am I subtracting the distance or adding it? Am I going left or right on the coordinate plane? 3 to -9, I'm going to the left, so it's subtracting. So originally, what did I do for the x's? I subtracted 12, right? Isn't that what I did? From 3 to -9. But I don't want to subtract 12. What do I want to subtract? 8. So I started at 3, and I'm going to subtract 8, and that's going to put me at -5. So the x value is going to be -5. -5 is 6 units to the left instead, sorry, 8 units to the left instead of 12 units. I don't want to go the full 12. I only want to go 2/3. So instead of going from 3 all the way to -9, I went from 3 to -5. Now let's do this for y. Y, I started at -2, right? And instead of, now, I went from -2 to +7. So what did I do with the y's? Did I go up or down? I went up, so I added. I started at -2 and I added 9, right? So instead of adding 9, I'm going to add 6, which is 4. So -2 plus 6 puts you at 4. So that is the point. That is 2/3 of the way from K to L. Again, you find out how far apart each of the coordinates are, what the total distance is for the x's, and the total distance for the y's. And once you've done that, then you figure out the fraction of that distance you want to travel. I didn't want to go 12. I only wanted to go 8. I wanted to go 2/3 of 12. That's 8. Then I had to decide, am I adding or subtracting 8? Because if I subtract 8, if I look at the original, I went to the left. Okay? There's a formula for this, and you can use the formula, but every time I have people use the formula, they get all messed up. Okay? And so a lot of you were doing it this way because we're working it out logically, so I'm going to leave it like this. Okay? So 3 minus 8 is -5. I started at -2 on the y, and I went up, but I didn't want to go up the full 9. I only wanted to go up 2/3 of that, so I only went up 6, so I ended up at 4 as opposed to 7. Okay. Okay, so if you look at the next one, you're doing the same exact thing on here, except for, and I'm trying to remember which one I labeled A and which one I labeled B. I think I labeled this one A, if I'm not mistaken, and this one B, yes, I think. Okay, so I want to go the fractional distance from A to B. Okay, so if I want to go from A to B, I'm going to start here and go here. Remember, this establishes your direction, A to B. So I'm going to do my fractional distance. So I've already got everything written the way I want to do it. Let's do the x-coordinates. What are my 2 x-coordinates? My x-coordinates, and I'll use pink because we've been using pink and most of you like pink. So I'm going to go from 10 to 7. So 10 minus +7 equals 3, which is 3. So to go from x to x, I'll put a little x-coordinate there, I went 3 units. So now let's look at y. Okay. To go from y to y, I went from 14 to 5. So 14 minus and a +5 is 9. So my y distance is 9. Now I don't want to go that full distance. If you look at the question, I only want to go 1/3 of the way. 1/3 only. So I'm going to take 1/3 of each of these. What's 1/3 of 3? 1. What's 1/3 of 9? 3. So instead of adding 3 or subtracting 3, or adding 9 or subtracting 9, I'm only going to travel 1 and 3. So let's go back and look at the original. I'm going from A to B, right? So I'm starting here and going here. What did I do with the x values? Did I go left or right or up or down? I went from 10 to 7. So I subtracted 3, right? So instead of subtracting 3, I'm going to subtract 1. So this one is going to be at 11. So my x value is going to be at 11. Again, what I did was I took my starting point, 10, not 11, sorry, 9, because I'm that good at math, 9. Because I started at 10, and I'm going to subtract 1. Now, for the y value, where did I start? I started at 14 and dropped down to 5, so I'm subtracting again. But I want to only subtract 3 this time instead of the full 9, 1/3 of that. So 10 minus 1 is 9. 14 minus 3 is 11. Okay, so the point is at 9, 11. So I'm at 9, and I'm looking for 11, right there. That is the point that is 1/3 of the distance that way, starting from A and going to B. And that's how you do fractional distance. So hopefully that helps you out with fractional distance. We've done all the fractional distance ones, okay? All right, so let's go on to the next. All right, these guys, parallel, perpendicular, or neither. Neither, we actually call those oblique. And that's something that's a vocabulary word we're not really going to use, but that's what they're called. So how do I determine if lines are parallel, perpendicular, or neither? Well, what do you know about parallel lines? Parallel lines have the same slope, okay? Perpendicular lines have what kind of slopes? Opposite reciprocals, okay? Opposite reciprocals. So let's look at these. Remember when you have an equation and it's in the format y equals mx plus b, which one, that's slope-intercept form, which one is your slope? M. M is your slope, okay? So let's look at number 8. Number 8, what is my slope of the first line? Positive 2 over 3. What's the slope of the second line? Negative 3 over 2. Are those the same? No, so they're not parallel. Are they opposite reciprocals? Is one positive and one negative and they're flipped? Yes. So these guys are perpendicular. Number 8's perpendicular. Opposite reciprocal slopes, okay? So let's look at number 9. On number 9, the slope of the first line is 2, which is the same thing as positive 2 over 1. The slope of the second line is positive 2 over 1. So what does that mean if it's positive 2 over 1 and positive 2 over 1? We've got the same slopes, which means these guys are parallel. They've got the same slope, exact same slope, so they're parallel, okay? All right, so let's look at the last one. If I look at the last one, I've got 3/4, positive 3 over 4, and negative 1 over 5. Are those the same? No, so they're not parallel. Are they opposite reciprocals? No, so they're not perpendicular, so they're neither. And we talked about this a little bit in class. We call those oblique lines, okay? So those are neither, okay? All right, so let's move on to the next one. Okay, so number 11. Oh, sorry, my back is hurting. I think I've said that about 4 times. Find the equation of a line that passes through negative 2, 4 and has, yes, the video is going to be on YouTube when I'm done. It'll be up there, okay? So the point negative 2, 4 has a slope of 5/6. Or sorry, the point, we have a line that travels through negative 2, 4 and has a slope of 5/6. So I want to find the equation. I'm going to do that 2 ways. Here's method 1. Method 1 is to use point slope. Okay, so point slope, if you remember, is y minus y1 equals m times x minus x1. You guys have had that pretty much ingrained in your brain. So what I'm going to do now is I'm going to plug in. I'm going to rewrite it. Okay, so I'm going to rewrite the equations as I always do, with everything left out that I need to plug in. And I do that so that I make sure I have all my negatives and my signs correct. Okay, so -2, 4. Your y value is 4, your x value is -2, and your slope is 5, 6. Okay, so now I'm set up to solve this. This is in point slope. Okay, now I'm set up to solve this. What I'm going to do next is I'm going to come over here. So y minus 4 equals, and now I'm going to distribute 5, 6 times x is 5, 6x. 5, 6 times -2. Well, is it a negative or is it a positive? What do I have? I have minus a negative. What does that change to? Plus a positive. So I have 5, 6 times +2, which is 10 over 6. Okay. But I'm not done yet. I want to get that y all by itself, and I can actually reduce that 10 over 6. So I'm going to add 4 to both sides, so I can isolate the y term. And I have 5 over 6x. 10 over 6 plus 4. Well, 10 over 6 reduces to what? 5/3, right? That's 5/3. And I want to add 4 over 1. Do you guys remember how to add fractions? Lowest common denominator, okay? So I'm going to multiply this by 3 over 3 so that I'll actually have 5/3 plus 12/3, which gives me 17/3, and that is my final answer. Okay, again, I have 5/3 plus 4 over 1. I have to make 4 over 1 match, have the same denominator, so I multiplied by 3 over 3, so that became 12 over 3. Now I can add them, 17 over 3. Method 2. Okay, method 2. Method 2 is to use slope-intercept from the get-go. So for example, slope-intercept is y equals mx plus b, right? Okay, so I have y equals mx plus b. I already know m, right? What's the slope of my line? It's 5/6. So I can plug in 5/6 for m. Do I already have a point on that line? Yes, I do. -2, 4. So any point on that line will make this equation work. That's what a linear equation is. So if I plug in 4 for y, and I plug in -2 for x, all I have to do is solve for b. So I have 4 equals -10 over 6 plus b. Okay, -10 over 6 plus b. I'm going to move the 10 6 over, plus 10 over 6, plus 10 over 6. And once again, I have that fractional. I have 4 over 1 plus 10 over 6. How do I get those guys to match? I could reduce that to 5/3, but that would be too much. That would be too easy for you guys. So I'm going to multiply this by 6 over 6. Okay. So now I'm going to have 24 over 6, common denominator, 10 over 6. So I get 34 over 6 when I add straight across, which is 17 over 3. So if I go back to my equation, I have y equals, what's my m again? I already know m is 5/6. And what's b? 17 over 3. These two guys are identical. Either method will work. Either method will work. You can use either one. All right, let's look at number 12. Number 12, find the slope of the line given those 2 points. Do you guys remember what slope is? Don't say rise over run. Change in y over change in x. So the slope formula is the vertical change over the horizontal change. Remember, sometimes we write that delta y over delta x, okay? So for my slope, I rewrite the formula again with the symbols in there because I'm going to plug in. I don't want to mess up my negatives. And I've got x and y and y. What are my two y values? -4 and +6. So I'm going to plug in -4 and +6 on top. Now I got to stay in the same order. What's on the bottom then? 11 and 9. 11 and 9. -4 minus 6 gives you -10. 11 minus 9 gives you +2. And a positive divided by a negative is a negative divided by positive is a negative. So your slope is -5, or you can write it as -5 over 1. That's all you have to do for slope. Okay. All right, let's look at 13 and put the following equation in slope-intercept form. Okay, slope-intercept form requires us to get the y value all by itself. We're looking for y equals mx plus b. Okay. So first thing I'm going to do is move that x term. So that's a 6x, so I'm going to subtract 6x from both sides. So -4y is left. Remember, don't be sloppy. Bring that sign down. That's a -4y. It stays -4y. Equals -6x plus 16. Okay. Now I've got -4y. The only step I have left is I don't want -4y. I want 1y. So I'm going to divide everything by -4. I'm going to divide everything. Let me repeat that. Everything by -4. So what that's going to end up getting is y equals negative over a negative is what? 3/2, right? Sorry, I've got my chair got hung up here. So you have +3 over 2x, and 16 divided by -4 is -4. And there is your slope-intercept form. Again, move the x term, divide by the coefficient of the y. Make sure you don't drop the sign, and that's slope-intercept. Okay, let's look at number 14. Find the equation of a line that passes through the point -2, 5 and is parallel to the line 6x plus 3y equals 12. Okay, so we're finding an equation. Anytime it asks you for an equation and it doesn't specify, we want slope-intercept, just because that's how we roll. So y equals mx plus b. All right. The point that you have is -2, 5. Right? And I'm looking for something. What does parallel mean? Same slope. It's parallel to this line. But be careful. You can't just grab the slope from that line. Why not? Well, in order to grab that slope, what format does this line have to be in? It has to be in slope-intercept. So let's put it there. So I'm going to take this line and put it in slope-intercept before I do anything. So I'm going to subtract the 6x from both sides. So 3y equals -6x plus 12. Remember, you cannot combine an x and a constant, just like you can't combine an x and a y. You don't have 10 apples and 5 oranges and end up with 15 oranges. It's just not possible, okay? So then I'm going to divide everything by that +3. So y equals -2x plus 4. Now I'm ready to go. What is the slope of this line? -2. I'm looking for the parallel to that line, right? So my point is -2, 5. My slope is -2 because I'm looking for the parallel slope. Same as this line. Now I'm ready to solve. You can use point slope or slope-intercept. It doesn't matter. I'm going to use point slope. Okay, so let's start plugging in. What's my coordinates here? My y coordinate is 5. My x coordinate is -2. What is my slope? My slope is -2 because I'm looking for a line parallel to that one. So now all I've got to do is solve it. So y minus 5 equals, distribute, -2 times x is -2x. What does minus and negative change to? You got it, plus a positive. So what's negative 2 times positive 2? Negative 4. And then I've got one more step. I want to get the y by itself. I'm going to add 5 to both sides. So we'll come up here. Y equals negative 2x plus 1. Negative 4 plus 5. This is the line that passes through that point and is parallel to that guy. Okay, that is a negative 2, by the way. I'm going to put it right there so you can see it. Notice how these two guys have the same slope? They're parallel. But this one passes through that point. That one doesn't. Okay. So we're going to do the same thing with the next one, which instead of finding parallel, we're going to find what? Perpendicular. So again, you see that word equation. Find the equation. It doesn't specify standard or slope-intercept. We're going to look for slope-intercept. Okay. That passes through this point and is perpendicular. What does perpendicular mean for slope? Opposite reciprocal, right? So I'm looking for an opposite reciprocal slope. And it's going to pass through this line here, 7x minus 5y equals 20. What's the problem with this line? Same thing as this one. This one's in standard, well, not really even in standard form because everything would be set up a little bit differently. But that's not in slope-intercepts. We got to put it there. So I'm going to take that 7x and I'm going to subtract it from both sides. And that's going to leave me negative 5y equals negative 7x plus 20. All I did was move the x term over. Don't be sloppy. That's negative 5y. Bring down the negative sign. And then I'm going to divide everything by negative 5. Everything, everything, everything. Okay? Everything. So you've got y equals 7 over 5x minus 4. Okay? That's my line. What's the slope of my line? 7 over 5, right? But what am I looking for? The opposite reciprocal slope, okay? I already know the point my line is going to go through. My line is going to go through this point, 8, negative 4. It tells me so, okay? I need the slope now. All I know about the slope is that it's perpendicular to this one. If this one's positive 7 over 5, then the slope I'm looking for is negative 5 over 7. Do y'all see how those are perpendiculars? So now we're ready to set this up and plug in, okay? So I'm going to use point slope. I'm going to use point slope. So y minus equals x minus, and let's do some plugging in. What are my points? Y is negative 4, x is 8. And what's my slope? My slope is negative 5 over 7. Again, I got that because I know it's perpendicular to this line. Okay? So I'm going to solve this now. And I've got y minus negative 4. That changes to y plus 4. And then I'm going to distribute. Negative 5 over 7x. And what's a negative times a negative? Positive. And I've got positive 40 over 7. There's not really a whole lot you can do with that. That's kind of just an ugly number. So the last step is going to be to get the y all by itself. So since I have positive 4, I'm going to subtract 4. Okay. So I'm going to come up here. Y equals negative 5 over 7x. And what's 40 over 7 minus 4? Well, if I want to combine the fractions, I have to have matching denominators, right? So I have to multiply this by 7 over 7. That makes that 28. What's 40 minus 28? That's 12 on top, and then 7 is still on the bottom. So there is your perpendicular. Look at the two slopes, negative 5 over 7, positive 7 over 5. Those are perpendiculars, okay? All right, so that's the perpendicular part. All right, so let's move on to the next page. All right, angles, or as some of you spell it, angels. Okay, draw a pair of adjacent angles. Remember, adjacent angles, sorry, adjusting again. Ugh. Adjacent angles share a side and a vertex, but no common interior points. All of yours are going to be different. And by the way, it should be like this. Draw a picture of. So what we're going to do is draw two angles. And like I said, uh-oh, here come the kids. They're getting ready to go to bed. So the two angles have to share a side. And they have to share a vertex. So let's make sure that they share a vertex. Okay. Okay, guys, I'm filming right now. Okay. Okay. All right, so they share a vertex. They also have to share a side. I'll come see you in a minute, okay? Night-night. I'll come see you in a minute. That was my daughter. So we've got they're sharing the side and they share the vertex. But remember, no common interior points. They can't overlap. So if you labeled these, angle ABC would be adjacent to, let's see here, let me pick from my color library, would be adjacent to angle CBD. Because they share a side and a vertex, but they don't overlap. That's a pretty drawing, honey. Thank you. It's for you. Oh, thank you. I can put a point in the interior of this angle, and it won't be in the interior of this angle. Remember, adjacent angles cannot overlap. So that's what an adjacent picture looks like. I can put a point in that angle, and they don't overlap. If I were to color them in so you could see them a little bit better, basically this angle right here, the purple one, is, I can hear my kids laughing, is adjacent to this one, okay? Remember, share a side, share a vertex, but they cannot overlap, okay? All right, so let's go to this one. Complementary, these aren't angles that pay you compliments. What does complementary mean? Complementary means they add up to 90 degrees, right? Okay, let me put these on here because this is going to drive me crazy. So complementary, remember you can change the C in complementary to a 9 and make that 90. Ooh, okay. So let's see what happens. JKL and MSN are complementary. That means it's an angle pair who has a sum of 90. JKL is 5x minus 12, MSN is 3x minus 2. What do I know about these guys? They're complementary, which means they are going to add to 90. So 5x minus 12 plus 3x minus 2 is going to equal 90 degrees. Okay? So 5x plus 3x, I'm going to combine like terms. And let's use different colors, just because I like using different colors. So 5x plus 3x is 8x. And then I'm going to combine my constants. I've got negative 12 and negative 2, which is negative 14. And that's all going to equal 90. Next, I'm going to solve for x, okay? So I'm going to add 14 to both sides. So 8x is equal to 104, right? Okay. Now I want to solve for x. I'm just going to divide by 8. So I divide both sides by 8. And what that gives me is x is equal to 13. Okay? But I'm not done yet. I now need to find the measures of both angles. I know x is 13. So what am I going to do with x? I'm going to take it and I'm going to plug it in for these guys. I'm going to plug it in there and I'm going to plug it in there. I'm going to verify that I got the correct angles. So, what color shall we use? Let's use blue, shall we? So let's check this guy first, JKL. 5x minus 12, which is 5 times 13 minus 12. Okay, 5 times 13 is 65, right? I hope so. That's what my brain said. So 65 minus 12 is 53. All right, so we know that the one angle is 53, and we know that the two angles should add up to what? 90. So let's check the other one. If I check the other angle, that's my MSN. That's 3x minus 2. If I do 3 times 13 minus 2, I get 39 minus 2, which is 37 degrees, right? What should these two guys add up to? they should add up to 90, right? Is 53 plus 37 equal to 90? Yes, so you have the right answers. Okay? So that's how you apply to complementary. Complementary, they're going to add up to 90. Okay? So let's go to the next one. We're getting through this pretty fast, guys. Let's go to the next one. Now we've got supplementary. What does supplementary angles add up to? 180 degrees. So these guys are going to add to 180. So I've got this angle here, HIJ, and this angle here, LED, and they're going to add up to 180. So 16x minus 20 plus 2x plus 2 equals 180 degrees. Okay? So now I'm going to solve this again with like terms because they like each other. So 16x plus 2x is 18x. I'm just using all these colors. And then negative 20 plus 2 is negative 18. And that's all going to equal 180 degrees. Again, because they're supplementary, I know they add up to 180. So the next thing I'm going to do is isolate the x. So I've got plus 18 and plus 18. So I'm going to end up with 18x, those go away, equals 198. I'm going to bring that up here because I'm running out of room. 18x equals 198. To solve algebraically, now I'm going to divide both sides by 18. So x is going to equal 11, okay? But I'm not done. I want to find x, and just like the other one, I want to find the measures. So I'm going to plug in. I'm going to plug in. So let's try HIJ first. HIJ is 16x minus 20. So let's plug in 11. I've got 16x, which is 11, minus 20. I'm just plugging in. That's going to give me 176 minus 20, which is 156 degrees. Okay, so that's what I got for the one angle. Remember, what should they add up to? 180. So let's check the other angle. The other angle is 2x plus 2. So I've got 2 times 11 plus 2. That's 22 plus 2, which is 24 degrees. Do 156 and 24 add up to 180? Yes, they do. So you know you got the right answer. Okay, so that's how you apply supplementary. Okay, so let's do a linear pair. All right. What can we do for linear pair? I'm trying to pick out a color. And no, I don't have a red marker. I don't know where my red marker went. I'm sure one of my little tiny humans in the house took it somewhere. Okay, so what is a linear pair? A linear pair, remember line pair? It's two angles that form a straight line. The technical definition is it's a pair of adjacent angles. Because aren't those adjacent? Don't they share a side and a vertex? Whose sides, one pair of sides forms a pair of opposite rays. You guys remember that. That's the technical definition. That is a linear pair. But remember what I told you, linear pair, I would let you accept for linear pair? Adjacent, supplementary angles. Because they're adjacent, right? And how do I know they're supplementary? What does a straight line add up to? A straight line adds up to 180. So your linear pair here would be angle ABC and angle CBD. Those guys are a linear pair. They form a straight line and they add up to 180 degrees. Okay? So that's all you had to put for a linear pair. Solve for the missing angles down here. I do not remember what I gave you. I think I gave you that this is 105 degrees, I believe. I don't remember what the letters are because I don't have the exact copy. Well, this angle and this angle are what we call vertical. Remember we talked about that vertical angle thing? What do you know about vertical angles? Vertical angles are always congruent. Always. So if that's 105, its vertical buddy is 105, okay? Now you've got a list on your review of all the angles over here. I don't remember what all the angles were, so don't worry about it. I'm just gonna show you how to do it. Now that I've got the one set of verticals, what can I say that I have here? If I trace this, what did you just draw in the previous picture? A linear pair, right? Isn't this a linear pair? If I were to cover this up, don't those guys make a straight line? Therefore, what do they add up to? 180. So this angle has to be 75 degrees because I have to have 180. Ah, but look what happens now. This angle and this angle are also what? Vertical. And what do you know about vertical angles? They're always congruent. So if this guy is 75, its vertical buddy is 75. Okay? So in addition to the vertical angles that you see here, we have 4 linear pairs. Okay? 75 and 105, 180, right? 75 and 105, 180. 75 and 105, 180. And I can't remember which one I'm missing. But anyway, they all end up 180. Sorry, I have rogue markers there. 180. 180. 180. 180. Okay, so you got 180. Those are all linear pairs. Okay. All right. It says to name a pair of vertical angles, but you can do that from the picture. I don't have that on the picture. And we're at the last page. Ouch. Let me see if I can reach it here without tearing my back up. My back is really bad right now. Okay, what is the angle addition postulate? The angle addition postulate says if we have an angle, and I'm not going to write out the whole definition. If we have an angle, ABD, let's say we have angle ABD, and we have point C in the interior. Oh, you'd actually like to see the definition. Oh, my bad. Point C in the interior of angle ABD. Whoops, that's D. So I'm going to draw point C. That's the interior. You understand what interior is, right? On the inside. Then it follows that if I've got C in the interior of ABD, then dot, 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 because I like to put dot, well, that should be 3 dots, not 4. Ignore me. I'm half asleep. Then, and I'm going to do this in color. You ready for this? The measure of angle ABC plus the measure of angle CBD equals the measure of angle ABD. Basically, little plus little equals big. That's the angle addition postulate. It's as simple as I'm going to make it, okay? Point C is in the interior. Just like with the segment addition postulate, sorry, something on my computer is in the way right now. I'm trying to get it off of there. So just like in the segment addition postulate, it says if point B is between points A and C, well, this is an interior point, okay? This is an interior point. Okay, so let's look at the very last one. Yay, celebrate! So on the last one, again, I'm trying to remember how I wrote it on your paper. Again, I had to choose cow just because in one, and con because I had to choose words because that's what we do in math. We choose words that are really boring. So I've got C-O-W. Okay, that's cow. For those of you that wanted to know that. That spells cow, moo. So we have 8x plus 15. That's this angle. Now notice I have it written like this. That's just to indicate its degrees. Don't let that confuse you. That's just proper notation. So it's 8x plus 15 degrees. Then I have angle WON, and that is 43 degrees, right? You know why? Because I said so. And then we have big guy, CON. And I'm going to put this on the outside. I'm going to put like a little purple line here and indicate it there. That is 20x minus 68 degrees. Okay? So the big guy is equal to, what did we just say in the previous question? If point C is in the interior, then the measure of the small plus the measure of the small equals the measure of the big, right? Okay. So let's look at what we have here. We've got the same scenario. We've got point W. W is our interior point, right? So the measure of angle cow, mu, plus the measure of angle 1 is going to equal the measure of angle con, right? Okay, so let's start plugging in. What is cow, besides an animal that gives us milk? Cow is 8x plus 15, right? And what's 1? 1 is 43. I'm just putting parentheses around it because sometimes when you do subtractions, the parentheses make sense. And altogether, these guys are going to add up to con, which is 20x minus 68. So I've got my equation now. So all I have to do is razzle-dazzle with algebra, and I got it figured out, okay? So I've got 8x plus, and what's positive 15 plus 43? Whoops, I can't even add. 15 and 43 is 58. Honey, hold on. My daughter's in here. Say hi, sweetheart.
Hi, hi.
No, you don't have to call them sweetheart. Okay, let me finish this one, okay? So you have to put your hand under here to say hi. Under here. Be careful. Under my phone. Say hi.
Hi.
Okay, go get in bed. I'll come check on you in a minute, okay? So I'm going to solve this. I'm going to solve this by getting all the x's. Oh, here comes the other one. Okay, I'm getting attacked by kids. Y'all both say hi. Say hi to everybody.
Hi, everybody.
Okay.
Hi, 145 students.
Oh my gosh, I can't believe she said that. Okay, so let me finish. So I'm going to subtract 8x from both sides. So I've got 58 equals 12x. I knew they were going to make an appearance. I just had no idea when. So my next one is, don't jump on the bed, plus 68. I'm going to add the 68 over here. So I've got 110, 126 equals 12x. And then I'm going to divide by 12.
I have pants on my head.
You have pants on your head. That's awesome. So, wow.
Mommy,
I hear you. So x is going to be 10 and a half. Oh my gosh, if you could see what my son is doing. So I'm trying to finish. I'm going to get this finished, dang it. So if I do 126 divided by 12, whoops, I get 10.5. Okay, just to show you where I got it. So x is 10.5. Now, find x and the measures of both. Let mommy finish. I'm on the last one. Okay, let me finish.
Ooh, look at her scarf.
I'm getting attacked right now. So I'm going to take 10.5. You guys see what I have to deal with? I've got pants on my head now. I've got pajama pants on my head. Y'all can't see it. It's very entertaining. So I'm going to take this 10.5 and I'm going to plug it in up here. So cow. Guys, hold on. Shh. Hey, shh. 8 times 10.5 plus 15. And 8 times 10.5 is 80. So 84 is 84 plus 15, which is 99.
Look at your new bath
Okay, wait, shh, let me finish. So I've got 99 degrees. If you want kids, this is what you're in for. And then for 20, I have 20x, so I plug in 10.5. Hey, let me finish. 68. I can't even begin to tell you what I look like. I have pajama pants on my head. So I've got 20. Can't concentrate anymore. I knew it was going to happen. So I've got 20 times 10.5, which is 210 because I don't want to think and I can't think with pajama pants on my head. Minus 68. Would you guys let me finish?
Look at your new hat.
Equals. Equals, sorry, 110. Sorry, 142. You guys are driving me bananas. All right, I'm trying to finish this. Okay. Guys. So, let me make sure. Let's check the math again. 8x plus 15, 43. So I got 58. And make sure I wrote it right. Equals 20x minus 68. So I have 8x plus 58 equals 20x minus 68. So 20 minus is 12x. And you got 110, so you got 126 divided by 12, which is 105, 10.5. Okay, I'm just making sure I did this right. So I've got 206 minus 68, so I'm getting this one. I'm getting this one as 142. This is why my life is crazy. So the question is, are these right? Turn the light on, please. Now. Now.
A night party.
This is important.
It's a dark party.
You've got to stop.
So,
according to this, the whole thing is 142, right? Can you please be quiet? According to this, the whole thing is 142. And what is that going to equal? That's 99, right? I'm so sorry. This is what happens. And 43. So 142 equals 99 plus 43. Is that a true statement? Yes, it is. So you've got the right angles. Sorry that one took so long. That's, oh my gosh. Anyway, so that is the review. And that should take care of everything that you're doing pretty much. If you have any other questions, you can look at them. I'm trying to get out of something right here on my computer. You can ask me tomorrow. Hopefully this helped you out. Sorry about the last one. I got attacked by little humans, and that's what happens. So anyway, that's the entire review. It's all done. And this is an hour, and I don't know how many minutes later we're finally finished, about an hour and 12 minutes. So anyway, hopefully that helped you guys out, and I will see you guys